Aurora, the stunningly harmonious color composition of the polar lights. Hello and welcome to our channel. Please subscribe to Z, leave a comment and enjoy the video. A natural light show in the sky known as an aurora can be seen exclusively at night and is most frequently seen in the lower polar areas. An aurora is a type of natural light show that appears in the sky as brightly colored lights that move and transform in shape like gently blowing curtains. Only at night and typically in the lower polar regions are auroras visible. Near the Arctic and Antarctic circles, which are located approximately 66.5 degrees north and south of the equator in the north, auroras can be seen most evenings. The display is known as Aurora Borealis, or the Northern Lights, whereas Aurora Australis, or the Southern Lights, is used in the south. The sun is where the action that causes the aurora starts. The sun is a ball of extremely hot gases composed of electrically charged particles called ions, and continuously flowing motions from the surface of the sun are known as solar winds. As the solar wind approaches the Earth, it comes into contact with the magnetic field. Without this magnetic field enclosing the planet and preventing the solar wind from doing so, the solar wind would destroy the planet's delicate atmosphere and extinguish all life. The magnetosphere blocks the majority of the solar wind and forces motions around the aircraft. The energy released by these collisions causes a colorful halo to form around the poles and the aurora when solar wind particles strike oxygen and nitrogen atoms in the Earth's atmosphere. The majority of auroras happen between 97 and 1,000 kilometers, 60 and 620 miles, above the surface of the Earth, and the solar wind's peak activity is when auroras are most active. Although the solar wind is often pretty steady, the daily heating and cooling of various portions of the sun can affect the solar climate. Sunspots are a common way to monitor solar climate. Sunspots are the sun's coolest region and can be seen as dark spots on its bright, scorching surface. Flares from the sun and ejecta coronal masses are connected to solar flares, solar ejections, and sunspots. Sudden extra energy bursts known as coronal mass occur in the solar wind. Bright and continuous auroras are most visible at the peak of sunspot activity, which is tracked throughout an 11-year cycle, and some increased wind activity also takes place. These predictable variations are referred to as magnetic storms during each equinox. During the spring and fall equinoxes, magnetic storms can cause auroras to be seen in the mid-latitudes. Auroras have even been spotted as far south as the Yucatan Peninsula in Mexico. Communications can occasionally be disrupted by magnetic storms and active auroras, which can also affect radio and radar signals. Even communication satellites can be rendered useless by powerful magnetic storms. If illusions meet with oxygen atoms high in the atmosphere, the contact results in a red glow, and the hue of the aurora depends on the height and type of atoms involved. This aurora display is remarkable compared to others. At lower altitudes, motions react with oxygen to generate a yellow-green tint. Ions striking nitrogen atoms cause the British and bluish light that frequently appears in the lowest edges of auroras. When is the greatest time of year to observe the Aurora Borealis? Although human eyes can really perceive this part of the electromagnetic spectrum, ions colliding with hydrogen and helium atoms can produce blue and purple auroras. Although they occur throughout the year, sightings are not possible from May to July, and for most of August, spring, and fall they typically provide more stable weather conditions and milder temperatures, plus there is increased aurora activity around the equinoxes from November to March. The northern lights are potentially visible under dark skies from late August to mid-April, preferably under clear, cloudless skies. Typically, there is too much light to observe the aurora. The lowest latitudes and the darkest months of the year are the exceptions. From mid-November to late January, tall as you walk to the bar where it's always dark, the northern lights are most common in the region below the auroral oval, which spans latitudes between 60 and 75 degrees and includes Iceland, parts of northern Sweden, Finland, Norway, Russia, Canada, and Alaska, as well as southern Greenland. Scotland and northern England, lights can be seen during extremely powerful solar storms. Although the majority of aurora activity happens within the oval, the activity of the aurora is not constant there because the appearance of light as a ring around the poles is constantly changing. As a result, a strong aurora in Sweden does not necessarily mean a strong aurora in Canada, and vice versa. The oval is monitored by space weather stations and is shown on forecast modules. The best places to view the Aurora Borealis from the UK are in northern Scandinavia and Iceland, but there are recognized spots all over the region that provide ideal conditions for sightings. It's important to stay away from sources of artificial light, such as street lighting, and to be close to open spaces that provide a great view of the sky because the northern lights are constantly changing. The patterns and shapes of the auroras are determined by the continuously changing magnetic fields and the stream of charged particles. Magnetic field lines are nearly vertical, which explains why auroras appear to be nearly vertical lightning bolts. Distinctive lightning bolts sweep across the sky in a dancing manner that occasionally moves fairly swiftly. The optical signatures of electrical currents moving up and down magnetic field lines are auroras. The phenomenon known as the aurora was first described and explained by a researcher from Nauru, who noted that plasma particles in the aurora move in response to the Earth's magnetic field, giving the aurora the appearance of shifting curtains of light. For thousands of years, mankind have been mesmerized by the breathtaking displays that periodically light up the night sky. Numerous tales and theories have been developed to attempt to explain what we now understand to be auroras. The Norwegian scientist Question, 1867 to 1917, was the first to explain the origins of the aurora, and as a result of his discovery, a whole new field of research was established: the relationship between the sun and the earth. In the year 1619, the name Aurora Borealis was first used as the name of the phenomenon known as the Aurora Borealis. However, until about 100 years ago, no one thought there was a connection to the sun. However, there are other names for the Aurora Borealis, including the Latin name for the Roman goddess of morning known as Aurora and the term Greek for the north wind known as Boreas. There is substantial debate regarding which astronomer perished. Galileo Galilei, who lived in Italy from 1564 to 1642, or Cindy, who lived in France from 1592 to 1600, were the first to give him their names. Captain James Cook dubbed the Southern Lights Aurora Australis between 1564 and 1642 after exploring the Antarctic. Captain James Scott named the same phenomenon Aurora Australis between 1770 and 2 to 75. The Latin origin of the name Australis is southerner, as is the literal translation. The Northern Lights' first recorded sighting. The first recorded mention of the aurora was made in China in the year 2600, and the text stated that it was Paula, mother of the Yellow Empire Joan, who observed an intense lightning strike moving around the Sioux star that belongs to the constellation Vado, and the light filled the entire area. These impressionist cave paintings, according to archaeologists, represent the northern and southern lights in the sky. Indigenous Australians have mentioned the Aurora Borealis in their oral histories. There are numerous similarities between Native American and Aboriginal societies, including how they interpret auroras as symbols of fire, death, blood, and omens. Numerous accounts have been written down. The unexplained claims of sounds being heard during oral presentations are less widely known examples of the phenomena known as oral sound. Numerous reports claim that during rural displays, a hiss followed by a higher-pitched crackle or clap might be heard. Although accounts of sounds made during aurora displays are less well known than the aurora's magnificent light displays, the most common colors seen in the Aurora Borealis are red and green, but other factors, such as whether or not electrons collide with oxygen or nitrogen, as well as the amount of energy these collisions produce, also affect the polar light's hues. For example, when oxygen and nitrogen combine, pink, purple, and white light are produced. Oxygen emits light that is either red or greenish-yellow in hue. Since our night vision is more sensitive to green light than to nitrogen, which often emits blue light, we are more likely to notice the green line emissions of oxygen. Some of the nitrogen emissions created by auroras are in the ultraviolet portion of the spectrum, which is invisible to us, and can sometimes seem blue or a combination of blue and purple-red. Alright everyone, thanks for watching and see you in the next video.